Alright, let's look at the practice exam 3, problem number 10, part C. Alright, so let's test this series. Alright, so on this one, you have natural log is there. Natural log is fairly difficult to deal with, so I'm going to use the integral test. Alright, so if you look at the corresponding, oh actually, I forgot to put these, this is going to be infinity here, right? But if you look at the integral, right, so corresponding one, so it's going to start from 2 to infinity. Right, you just have to replace n with x. You don't really have to, but since we're used to x, so it maybe looks more familiar. So you have x, and you have a natural log of x cubed, and with respect to x. All right. So let's evaluate this limit, not the limit, integral. All right, so for this one, I'm going to use the substitution. I'm going to let u be natural log of x. All right, so if you take the derivative of u with respect to x, you get derivative of natural log of is 1 over x. And then we're going to take the reciprocal of both sides, so you have a dx over du equals x. Then we can simply multiply through by du, so that dx is isolated. So you have x times du. All right, then we have to do the converting the limits here. So you have x is initially going from 2 to infinity, so you have to convert it to a corresponding u value. So u is natural log of x, so when x is 2, it's going to be natural log of 2. Right? Natural log of infinity is still infinity, so I'm going to write down infinity here. Alright, so this improper integral can be rewritten as integral from natural log of 2 to infinity. And you have 1 over, and I'm going to leave x as it is because we can cancel later. And natural log of x is u, so that's the substitution. You have to cube it. And dx, we know that can be rewritten as x times du, so we get that. Alright, then we can do a cancellation here because we have to get rid of all the x's, so we got that. Alright, then after that, we just have to, okay, so this is improper integral, so we would have to replace the infinity by, say, t. And you have a natural log of 2 is okay. And we have a limit as t approaches infinity, right? Alright, and I don't like fractions, so I'm going to write 1 over u cubed as u to the negative 3 power. Then we want to take the antiderivative with respect to u. Alright, so let's find the antiderivative. So we'll take care of this limit later. So you have a limit as t approaches infinity. Alright, so antiderivative of u to the negative 3 would be add 1 to the power, so it's negative 2, and divide by negative 2. Alright, then you're going from natural log of 2 to t. Alright, so this is going to be, let's see, so you have a limit as t approaches infinity. Alright, so this guy, I don't like the way it's written, so I'm going to rewrite it. So this guy can be rewritten as, right, there's a negative sign, and there's 2 on the bottom, and there's a negative power, so you have a u squared on the bottom, right? Alright, so I'm going to plug in t, so you're going to get this, right, negative 1 over 2 times t squared on the bottom, right, minus, and negative, so it's going to be positive 1 over 2 times natural log of 2 squared. Right? Maybe I should put a bracket here. Alright, so I'm going to just erase this guy, and then I'm going to just put the bracket here. Alright, but as t approaches infinity, we know that this guy right here, the first term, approaches 0. So this guy goes away, and you are left with that second constant there, which is 1 over, right, 2 times natural log of 2 squared. Right? We don't really care what kind of number that is, but we just get a finite number, which means that this improper integral, corresponding integral, converges. Right? So by integral test, we know that the corresponding series is going to be convergent. So this guy is going to be convergent. Right? So this guy is convergent. And by integral test. All right, that's it. I hope that this was clear.